Hi guys, in this video we will see the Kubernetes concept horizontal pod autoscaler, also known as HPA. Why we need HPA? Let's talk about it. Let's say you have built an application like Flipkart, a Next.js application, e-commerce web application like Flipkart, and in Flipkart there is a sale like big billion sale. The big billion sale starts at night. Let's say if you start at night the sale, the traffic comes very fast. सेल में बहुत लोग जल्दी बुक कर देते हैं, जैसे मोबाइल फ़ोन आईफोन पे सेल लगी है 20-30%. So people comes very fast, so the traffic gets increased and the load on your machine also gets increased. As a DevOps engineer, you don't want to कि आपको रात के 1-2 बजे उठाया जाए कि इसको स्केल कर दो. You don't want to scale your application at night manually, neither in ArgoCD, no, like you scale the replicas inside the ops repo. So for this we use the HPA. We scale the pods according to the CPU या फिर मेमोरी रैम के हिसाब से, according to the CPU and the RAM usage. So what HPA does, it automatically adjusts the pod replicas inside your deployments, replica sets, stateful sets, whatever you have made. The HPA will automatically increase and decrease the pod according to the CPU and memory usage. And this is the HPA. Let's talk about what is horizontal scaling means. Horizontal scaling, it is like you increasing the pod. You are increasing more pod to your worker node, more pod in your worker node. You are not scaling like vertically means कि आप उसके रिसोर्स नहीं बढ़ा रहे हो पॉड के, जैसे मैंने मशीन बढ़ा दी, जैसे यू आर नॉट इंक्रीजिंग द रिसोर्सेज ऑफ द वर्कर नोड. मैंने इस मशीन का साइज़ 4 CPU कर दिया, 4 कोर की मशीन है, इसमें 32 GB रैम की मशीन. इट्स द वर्टिकल स्केलिंग. वी आर टॉकिंग अबाउट द हॉरिजॉन्टल स्केलिंग. हॉरिजॉन्टल स्केलिंग मीन्स we will either increase the pod replicas or decrease the pod replicas according to the CPU and memory usage. Let's say it is your worker node and your Flipkart application pods running. This is your load balancer, let's say your ingress load balancer. We will not use ingress in this video because we don't need. So it will route all your traffics to more nodes. Let's say at night the worker, जो ट्रैफिक आएगा वो स्पीड से आएगा. जैसे ही सेल स्टार्ट होगी, लोग पहले से ही रेडी रहते हैं बुक करने के लिए मोबाइल फ़ोन्स, लैपटॉप्स, whatever you want to order. The traffic comes very fast. बहुत तेज ट्रैफिक आ रहा है. योर मशीन विल गेट हीटेड अप एंड यू डोंट वांट टू स्केल अप मैनुअली एट नाइट. आप अपनी नींद ख़राब करके आप पॉड ऑटो स्केल नहीं करोगे. सो दैट्स वाई वी यूज़ द HPA. आई एम रिपीटिंग अगेन बिकॉज आई एम डूइंग इट लाइक दिस. ड्राइंग में कर रहा हूँ मैं इन अ फिगर वे टू अंडरस्टैंड बेटर. So what will ऐसे ट्रैफिक आया, हमारे ये वर्कर नोड की मशीन हीट अप हो गई क्योंकि इसमें अभी हमारा एक ही पॉड चल रहा है. वी आर नॉट यूजिंग फॉर करेंट सिचुएशन, वी आर नॉट यूजिंग द HPA. our worker node machine gets spiked up, उसका CPU यूजेज स्पाइक हो गया, मेमोरी यूजेज भी स्पाइक कर गया. सो योर पॉड विल आइदर क्रैश ही हो जाएगा. आइदर क्या है, योर पॉड विल क्रैश आउट. एंड what will be the solution? You will wake up at night and you will manually apply either in a ops repo or manually go to the cluster and you will apply the kubectl scale this deployment replicas 15 replicas कर दो. You will do like this if you are not using the HPA. after using HPA you will decide कि इतना मेरा CPU usage हो. we will understand the concept of HPA. और let's say 100 M है हमारा CPU usage. M meaning milli cores. 100 M means 0.1 core. 1000 M 1 core, 1 CPU. We are using cluster in a T3 dot small machine. Our worker node uses T3 dot small, so means T3 dot small we have 2 cores or 2 CPU. Let's say if we use the HPA we will write like this. अगर हमारा ये जो पॉड है, जो कंटेनर है, we will give this. Let me see my audio. Yes, if the pod, the container, it is running this application, the CPU will spiked up to this 100 millicores. The pod will the new pod will automatically gets created. मतलब automatically replica बन जाएगा उसका. So it will एक और replica बन जाएगा और then it will be distributed your traffic. Then your application will be run fine, your sale will go smoothly. So let's understand the basic concept. There are two things only. Before using the HPA, before creating the HPA manifest, we will have to install one thing in our cluster, that is called metrics server. We have already worked with metrics in the Prometheus phase, in the phase 3. What metrics server does, it will like expose your metrics of the node and the pods, how much CPU and memory it is consuming. So it will expose the metric server, and then this, when we create this HPA, it will talk to this metric server and create the replicas when the condition will hit कि कितना CPU usage हुआ है, condition will hit and the new pod will get created. So in cluster we have to do the first thing, install this metric server. We will install it. There's two more concept in HPAs. First one is we give resources to the containers when in the deployments. When we give the pod template, we also give the resource to the container कि your limits and requests are these. We will learn about what are limits and resource. मतलब हमारे पास इतना ही है कि ये कंटेनर इतना ही CPU यूसेज करे. So we have to give a resource inside our deployment for the container. Let's understand what I am talking about. In the resources we give two things. Let me write it. We give two things in the resources. We give two things, request and limits. Limits, let's first understand about the request. In request, what does this request do? The kubelet reserves this much of CPU for this container. Let's say we have requested the container 100 millicores. So the kubelet will reserve this much of CPU to this container only. No one will use that. If you create another pod, the another pod will not use this CPU. This CPU storage, think of it like a storage. It's a reserve. It's reserved for this container only, the running container only. Who reserves this? The kubelet reserves this. We have already understand how the architecture of Kubernetes works. We have already understand about the kubelet. So that's how the request work. And the limit we do कि the maximum limit this container, the maximum CPU usage this container can use. इसके आगे वो यूज़ ही नहीं कर सकता, इससे ज़्यादा वो यूज़ ही नहीं कर सकता. Let's say we have request for 100 and we have set a limit for 500 millicore. 100 millicore तो उसको रिजर्व है, उसको जगह मिल चुकी है. But 500 millicores is the कि वो maximum this much of usage can hit. The container can hit this much of CPU usage. So that's the request and limits. We will see in the code. I have already created the HPA and this resource. I will give you an overview inside my ops repo, and I'm working with Helm charts. I will show you Helm charts कि मेरे को दोबारा डिप्लॉयमेंट, नेम स्पेस, इंग्रेस, सर्विस कुछ भी लिखना ना पड़े. सो आई विल यूज हेल्म चार्ट. आई विल ओनली अपडेट द वैल्यूज़ इन द वैल्यूज़ फाइल, नॉट गोइंग टू अपडेट. मैं अलग से नहीं बनाऊंगा सारी मैनिफेस्ट. इट्स अ गुड very important topic is this Helm chart, widely using in this field. मैनिफेस्ट आजकल कोई कंपनी नहीं पूछती है, मतलब अभी मार्केट में ये है. You should know the Helm charts. So let's see. First I will give you an overview about my app. I have created a CPU intensive app कि जिससे हमारे CPU बढ़ जाए और we can see the pod scaling and down scaling in the cluster, and we will monitor, मतलब we will see the auto scaling in the UI using ArgoCD UI. I hope you know ArgoCD. You can watch my video and you will understand very much about it. Then you don't have to watch any video. So let me give an overview about my CPU intensive application. It's a basic Node.js app. I have nothing installed, a simple Node.js app npm init-y. You can simply create it. I have installed one library just to see the output on the screen. इसका भी कोई ज़्यादा काम नहीं है. You can make a CPU intensive but without using this express. हमको फंक्शन ही तो रन करना है. and I've already created the Docker file. It's the much better Docker file. We have already seen about this in the raw Docker Node.js Docker file. What's the change? What are the cache layers? How layer works? We have already understand in the Docker video. It's a 1 hour video. If you haven't watched this, you can watch that. So in dot, I make a dot docker ignore file node modules. I don't want it to copy inside my working directory inside my container. So that's the simple Docker file. Node 23 image I am using. Working directory /f. First I'm copying these two package files. Then I am installing the dependency like express. Then I am copying the code. Then I am exposing my 3000 port. Then cmd command. When the container will start, it will run this command. Simple. Let's see inside the Next.js. We have already know about all of this. First thing is import cluster. We will see what is cluster is. Import OS. You can find out the CPUs from this OS dependency or module कह लो कुछ भी कह लो. And this express we are using because the HTTP request. First we are finding the const number of CPUs कि हमारी t3.small यूज़ कर रहे हैं तो we are limiting to only 2 cores. ये मिनिमम फाइंड कर देगा 2 या फिर अगर हमारे os.cpus ज़्यादा हैं 4 और 2 में से it will only use 2 because we are setting a minimum. If cluster dot is primary console जब पहली बार जब what is cluster? JavaScript is a single threaded language. It does not work on multi threads. So by using the cluster we can run our app in Node.js instances in multi threads in different threads. So when this started, जब भी वो दूसरे थ्रेड पर चलेगा this will get log, a new ID will run, and when the number of CPUs hit, then it will again create an instance of this Node.js app. If it is मतलब अभी वो चल रहा है किसी थ्रेड में, so we will run this code. We are setting up our express set interval. What it is doing, it is running in every second, every 0 second, and we are increasing the pods within the 200 millisecond time frame. It's a simple loop while date.now is less than end. When the date.now hit this end, it will automatically get ended and will run again, and our CPU, our pod will created again. और जितने भी हमारे CPU हिट हो जाएंगे फिर वो दोबारा डीस्केल कर देगा, फिर वो फर्स्ट से चालू होगा. We will see like this: 0 to 1 pod, 1 to 2 pod, 2 to 3 pod, 3 to 4 pod, 4 to 5 pod, 5 pod. Then this will use our 2 cores because the 500 we will give the limit, the resource limit, the 500 millicore, that is equal to the 0.5 core or CPU. So 0.51 इधर से चालू हुआ ना 1, this 2 will get 1, this will get 2. So our t3.small is 2 cores machine. So our all CPU use हो जाएंगे, then it will fork it again. So after 5 pods it will start with again 1. So that's the overview, मोटा मोटा overview दे दिया है, कुछ ज़्यादा नहीं है. Just to see the HPA I have write this, nothing fancy here. So let's see our started or not. Our cluster is created. Let's clear it. I have already installed. Let me clear it. I have already installed the ArgoCD kubectl get namespace. You can see ArgoCD has been installed. To work with HPA, what I have tell you, we have to install what? Metrics server HPA manifest. AI will give commands. We have to apply this manifest, copy this, go to your cluster, if I write, let me clear the screen, if I write kubectl top, what's the top command in Mac? I think it will give you the usage of the CPU. In the cluster it will give the usage of what you want to know. Pods, it will give the usage of pods. And if you to find about the CPU and memory usage of the nodes, you can write the command kubectl top nodes. It will say matrix API not available, because in the matrix AI we have to add some arguments. There are the arguments. Copy this. First we have to run this command in our matrix deployments. We have to change something. Come to the containers, arguments, copy the arguments here, paste it right there, and escape :wq. So the deployment that we have edited will automatically get supplied after it. So no need to apply like kubectl apply this deployment. So no need. When we use the edit command and when we close the editor, it will automatically get supplied. I think that's we have already learned. Now if we write kubectl top nodes, matrix API not available. Let me see. As you can see, now it is working. What I have done, I have deleted the manifest file, then I have reapplied it, then I have added the arguments inside the deployment of this matrix server. Now I am writing kubectl top nodes. It is giving me the CPU usage of the node and the memory it is consuming, and that's the basic basic metrics about the nodes. These are two worker nodes. If I write kubectl top pods, you will see nothing. If I write ArgoCD में देख लेते हैं, you will see these are the pods running inside the ArgoCD namespace and how much core it is. It's the 1 millicore, very less. मेमोरी ज़्यादा कंज्यूम करते हैं ये pods. इसीलिए जब आप ज़्यादा कंट्रोलर यूज़ करो इन अ स्मॉल मशीन, कभी कभी वो हमारे चलते नहीं है. If you get something error, make sure you use, if you use more controllers, many controllers. Make sure you are using a good specification machine in your instances, in your as a worker node. So we have seen this, we have installed the metric server. Let's go to our GitHub. That's repo, we have already made it. Yes, one thing, hub.docker.com. I've already pushed this image to the Docker hub. You can also use this image if you want. It's a public image. You can see the URL. So it's a लेटेस्ट वाली मत करना, the CPU usage 2 वाली है. Latest wali, what I was running in the latest image, I was trying to increase the CPU usage by running a big loop, but जो रिक्वेस्ट हमारी जो सेम ब्राउज़र से जाती है वो एक ही पॉड को जाती है और ज़्यादा हमारा CPU यूजेज बढ़ नहीं पाता. Now in this 2 we are using multi-thread. We are creating the Node.js multi-thread instance also. So let's see inside. I have created a values2.yml. That's not a specific chart. आपकी एक ही values.yml. You can use the chart templates again and again, but you should have your values2.values YAML different. I'm using it in this just for demo purpose. Make sure you created your own in the separate chart like CPU app chart. Templates are same. In the deployment we have added the resources also. Let me zoom it. As you can see, we write the resources inside containers because we have to give resources to the containers. Resources request इतना क्यूबलेट ने हमारे लिए रिजर्व कर दिया है. This much of CPU reserves for this container by the kubelet, and this much of maximum limit we can hit the CPU. That's our resources, container resources. Let me zoom out. We go back to the templates. I have added a HPA.file. That's the if else case अगर enabled है तो जब ही चलो. I was testing something. Yes. API version we use. Let me zoom it. Just understand first, don't write it. API version autoscaling /v2. When we install the metric server, the horizontal pod autoscaler controller also gets installed. So don't get confused how this kind is working. Metadata, release name, we have already understand what are release name. HPA, scale target ref, किस चीज को टारगेट करना है, क्या स्केल करना है. We have to scale and deployment. What's the API version of deployment? Let me see my audio. The kind of deployment, the name of the deployment, make sure it is same as this. Where's the, make sure you are using the same deployment name in the HP also if you want to scale the deployment pods. Minimum replicas, कितने डाउन स्केल होने चाहिए व्हेन देयर इज नो ट्रैफिक, मिनिमम रेप्लिकास कितने रन करने चाहिए, मैक्सिमम रेप्लिकास कितने रेप्लिकास स्केल होने चाहिए, मैट्रिक्स किस टाइप का है, वी आर गिविंग द मैट्रिक्स टाइप रिसोर्स, यू कैन गिव अ कस्टम मैट्रिक ऑल्सो, नेम क्या है रिसोर्स का, CPU, target utilization, average utilization we have given inside the value. Oh, we have not understand the average utilizations, how the scaling works. Let's see, formula use होता है इसके अंदर. Let's say this is our worker node. No one will teach you like this, I don't think so. मेरे को तो कोई कोर्स नहीं मिला अभी तक. So let's say this is your worker node, your one Flipkart node using 60% of CPU and your another Flipkart using say कितना 70% of your CPU, and in HPA you have given the average utilization कि कितना मिनिमम यूटिलाइजेशन होना चाहिए टू स्केल होने के लिए. लेट्स से in this we will give like 50% average. So how will it scale? Let's say 60 plus 70, what is it? 130. 60 plus 70, and then it will divide by 50. 130 50 5 2 जा 2 पॉइंट कितना हो गया, 2.6 हो गया ना. हाँ, सो 2.6 आया इसका आंसर, मतलब. एंड इट्स यूजेस लाइक फ्लोर वैल्यू, फ्लोर ही होता है ना जब वो 3 हो. सीलिंग या फ्लोर कौन सा, व्हेन इट गेट्स, जब भी कोई पॉइंट में होती है, वेन एवर देयर इज अ वैल्यू इन डेसिमल, it will take it as a next value. It's a floor I think, या सीलिंग वैल्यू होती है, मैं भूल रहा हूँ. So it will get the next value. So what number we have got? 3. So the HPA will scale a सिंगल पॉड, मतलब 3 पॉड चल जाएंगे अब टोटल. इन द CPU यूटिलाइजेशन विल गेट स्प्रेडेड, मतलब डिस्ट्रीब्यूट हो जाएगा, लोड भी डिस्ट्रीब्यूट हो जाएगा, CPU यूटिलाइजेशन भी कम हो जाएगा, एंड आवर pods will automatically get scaled up. So that's how this scaling works. ऐसे नहीं है कि वो अपने आप स्केल हो जाता हो. So that's our horizontal pod autoscaler. If I go to my chart in values 2.yml, I have given the replica count as 1 कि 1 से start हो वो. Repository this, tag of the image this, service enable true. We are creating a load balancer, we are not using the ingress. I don't, ingress की हमें कोई need ही नहीं है. Ingress enabled false, so ingress will not use. HPA enabled true, so HPA will use inside this chart. Minimum replicas are 2, 5 and target CPU utilization. The average CPU utilization is 50. So that's our chart. Let's create our application, ArgoCD application. Let me clear the screen. First, let me log into the ArgoCD UI. kubectl get, what first thing we have to do, we have to get the password from the ArgoCD secret. inside this initial admin secret, kubectl gets secret hyphen o json path dot data dot password and make it base 64 decoded. So that's our password. Let's put forward our ArgoCD UI. I hope you get fluent in this. हाथ सेट हो गया होगा अभी तक तो आपका. In which names service the UI is exposed in this service ArgoCD server. This 80 and 443. You can run any of it, any one port of it. So we will port forward instead of making a separate load balancer service for it. We will use the port forward जब हमें Kubernetes ने provide करी है ऐसी technology, so why should we not use it? Port forward service inside the namespace of ArgoCD 8080, which port 80. Yeah, I'm using an instance, so I will write address. It will port forward our screen. Go to your instance, copy your public IP, paste it, 8080 port, advance, yes, proceed. Username is admin, password we have already decoded it. This is our password, and there's no application is running. We are inside our ArgoCD UI. If I go to my let me clear the screen, go to my K8s.yaml, there will be a application.yaml .yaml. What's this? Not inside this, the application helm.yaml. We have already seen this. If you are getting confused, make sure you watch the Helm video of this playlist. You will understand what I am doing this. What are these? How to create these? What are values.application? What are the source and destination? Make sure you watch that video. Insert it. I'm using the values 2.yaml. Yeah, same. Repo URL same, path same. Create namespace also true. Let me change the name. It's not a next application, it is CPU application. And namespace CPU application. Escape :wq kubectl apply -f application helm.yaml. By application is created, let me port forward the ArgoCD UI. Let me refresh. Our app is created. ये क्या हो गया? Revision head must be resolved. Let me see what's the problem. If I go, there was a, let me check my audio first. Hello. So there was a stupid error. The error was in my application.helm YAML, the Helm was finding the values to.yaml, the YAML. But in my ops repo, if you will see the values to.yml, it is there. So I have to write the YML. Insert it YML. Now I hope it will work fine. I will create my application. I have deleted it. You can see clue cuttle delete hyphen apply hyphen f application helm.yaml. Application is created. Let me put forward the ArgoCD UI. Our ArgoCD is working. Application synced. You can see HPA is created, service deploy. Now you will see what the pod will automatically get scaled up and scaled down. Now let's see this. If you will see now are 3 pods. It is terminating, running. If you see the events of the deployment, scaled up replica sets to 1, scaled down 1 to 2, scaled up 1 to 2, scaled down 2 to 1. Pending container creating, it is deleting, it will gradually add. See the logs of the deployment. Refresh नहीं है क्या ये? Refreshed. Now see the logs 1 to 2, 2 to 1. Container creating, 2 pods are running. You will see now 4 of them are running. 4th one is creating. We can see the 5 pods if we wait. See 5 pods are running. Now it will go back to the 1. Now it will automatically deleting, scaling down, scaling up. HPA automatically scaled up and scaled down. That's a very important Kubernetes interview question. Some pods are running, some are creating, some are terminating. So that's our HPA. If we see the logs of the deployment, you can see 0 to 1, 2 to 1 scaled down, 5 to 1 scaled down, 1 to 2, 2 to 4, 4 to 5 scaled up. Automatically it is working. So that's the horizontal pod autoscaler. Now we have completed it. So our playlist is almost done. I will see what are the remaining videos. So thank you for this video. Okay, make sure you delete your cluster, otherwise you will get charged for this. Thank you.